Okay, I believe I'm live, and I have one viewer. Hey Xander. In case you're wondering, the music is beachside holiday Nintendo music. Yeah. In terms of band 6 questions, they've asked quite a range. Like this kind of covers everything, and it's kind of like one from each topic. So I think that's kind of cool. Oh my god, we have a second viewer. And back to one. Do you want to try and, I don't know if you've seen these before, but do you want to try and guess them first? Perhaps. I don't know. I guess I'll just read through them. So the first one basically says there's a function, it's got an inverse, and the inverse forms part of, let me reconstruct my pen. Inverse forms part of that quartic. And then there's a diagram over here that shows you that quartic, and it basically says the original and the inverse, how many times do they cross each other? Yes, I can do that. There we go. So the original was, where is it? That's the original. That looks kind of gross. I don't know where to put my coffee. Well, when I was looking at this, we're just going to go through the three. There's only 3 multiple choice that are considered band 6 questions. So I have like written solutions to these, but I tried to do them without like looking at them first. And the first thing I was trying to, the first thing I was trying to do was kind of think, well, how does this even relate to this? And I quickly realized that this is literally just rearranged to form this, and I wasn't really sure how you'd go about, because like this is borderline impossible to graph. Like, how would you even draw this? So my line of thinking was kind of, well, maybe I'll this is already drawn. Maybe I'll consider where this isn't, I suppose, and maybe that'll help. So that's kind of where I went. But yeah, if you have a guess. My guess was kind of like, well, if this is a quartic and I'm looking at this weird square root function, which probably looks all over the place. I haven't actually looked at what it looks like, but I'm assuming it's kind of weird. I would have thought that it would have crossed perhaps more than once. So I would have considered 1 maybe a silly answer. And then I don't know about it crossing 4 times, because a quartic only turns 3 times. So I was kind of expecting a solution between 2 and 3. That's, I guess, where my head was going. I suppose I'll go through it. I'm trying, I can't really put a question. So the first thing I kind of did was, I didn't really know what this quartic thing was kind of telling me. So I guess I started by, let's go with 1. So what's the equation? Like, I thought this was kind of a weird, you probably guessed 3. Yeah, I was thinking like 2 or 3. So I started by just rearranging this to see what it looked like. And I quickly discovered that I'd be wasting my time. But I guess it kind of comes from, if I would have rearranged this, then, you know, you've got to square something twice. So I guess if you were smart, you'd kind of think, well, I've squared something twice, I'm probably going to end up with a quartic. So what ends up happening is when you rearrange this, you end up with this. So I'll just show you, but this is what I pretty much did. So I was like, okay, y equals that, and I'll swap them. So minus 1 plus 1 plus y. And then I just started, like, I moved the minus over here, and then I squared everything, so then the minus kind of disappears, which is kind of getting rid of a solution. So I don't know if that's perfectly legal. I think that's why it tells you that it gives you part of the graph rather than the whole graph. So I've got 1 plus root 1 plus y, and I moved the 1 over, and I squared it again, so then I ended up with 1 plus y. and I had y equals, and I expanded everything, so that's x4, and you can see where the 4 comes from now, minus 2x squared plus 1, and then when you move the 1, it's minus 1, so then I've got what the question already gave me, so that was kind of a waste of time, and I felt pretty stupid when I did that. And then I was thinking, well, if you're looking for when these cross, so you're looking for when this crosses this, they've already given us this. This is like impossible to draw. So I was just thinking about, there's 2 square roots on here, so maybe it might make sense to think about where it doesn't exist. So then I started kind of just drew maybe I'll do it over here. I'll do it on the graph. So y equals minus 1 plus, 1 plus y, x. So I guess the domain, so I went with domain and range. The domain, obviously 1 plus x has to be greater than or equal to 0, so that part in there. Then I rearranged it, so it had to be bigger than minus 1, and I kind of drew that on the graph, so minus x is minus 1. Did I stuff that up already? Nope. I feel like I stuffed that up in the... No, I didn't. So that means here, it means it can equal minus 1, so that's kind of nice. So that means potentially those are 2 points on the graph. That looks weird when I draw it like that. But basically it's undefined here, which is kind of strange. So then I'm looking for a maximum of 2 points, because these are the only 2 points that possibly exist. So then I went, okay, well, range, what's my range look like? Well, and this is probably mathematically gross, but like I don't know, when I look at range, I just kind of think, what's the smallest thing I can plug in, and then what's the biggest thing I can plug in? So 1 plus root 1 plus, and then, so this one, the smallest thing I can plug in is, well, minus 1. Now when you put minus 1 into there, you end up with, that's 0, and then that's the root 1, so that's actually equal to minus 1. So then the point minus 1 is on both graphs, because that's here, so that's definitely 1 point. Then the range, I just put like 9, 9, 9, 9, and I ended up with something like 5, or sorry, minus 5. So that tells me that the whole graph is just continually decreasing, and if it starts here and just decreases, then it just kind of goes down here, and it never actually touches here. So I guess the only real point that is on the graph is this one. So the answer is just 1, which was not what I was guessing at all. But it's kind of weird, and I'm pretty curious I haven't actually graphed it, but I'm curious what this thing looks like. But yeah, reading off for 7 minutes. Being a multiple choice, like this was, I looked up where this was. This is like a question 10. So you'd expect your question 10 to be kind of hard. Oh. Okay. So the second one, try and put this over here. Is that going to fit there? Oh yeah. Oh, come on. So I hope that's viewable. It's pretty small. But aren't we supposed to graph the inverse? Yeah. No, they've graphed the inverse, so that is the inverse. Yeah, so it's kind of like saying the original and the inverse, what do they have in common? Well, here's part of the inverse. So here's part of the inverse. Tell me what the original function looks like. So they've given us the inverse, and then I just kind of looked at where the original function even exists, and only there, and then somewhere down here, I guess. This is cool, asking questions live. I hope that makes sense. But yeah, it's a very intimidating question looking at something like that, I guess. Alright, well this next one's a bit of a doozy. So I wrote up nice solutions to these, and you'll notice in the nice solutions, I hate combinatorics. It's by far the hardest topic in extension, I reckon. Extension 1 and 2, I'd probably argue, but yeah. So it's basically saying there's an access code that has 4 digits, and I can choose from any digit, but it needs to be in the correct order, so I would assume that we're talking about permutation here. Now, some access codes contain exactly 2 digits. So how many such access codes can be created? So I'm looking for a 4-digit thing, but I can only use 2 digits. So I was kind of thinking, well, you could go case by case. So like, let's go over here. I had a few arguments with another teacher about this question because, I don't know, I wasn't really convinced by the answer, but I am a little bit more now. Like I said, I hate combinatorics. So you're looking for a 4-digit pin, but I can only use 2. You got 360. Is this for the combinatorics question? Yeah, that's one case, I think. So you got to think about, like, I just use A and B, so pretend A and B are like numbers, which is kind of stupid, but your first case is where you use 1 of one and then 3 of the other, and then the second case is when you use 2 of each, if that kind of makes sense. I seriously think this is a pretty hard question. Yeah, okay. Look, I kind of went with 3 ways to do this because I feel like I spent ages on this. And again, and see how it's got, so like up here, it's got this little dash on it. This was actually an extension 2 question, and combinatorics wasn't in extension 2. You basically just said using polynomials is stupid. Yeah, kind of. Like, it's counterintuitive, and I'll tell you why in a sec. But I feel like I'm shouting. I don't know why I'm shouting. Yeah, so this used to be an extension 2 question, which was like harder. Extension 1 needs to be probably called that. Okay, so the 2 cases. Let me just move away from that for a sec. Let's go with method A. And it was kind of like, all right, well, I've got, how many configurations can I kind of have? Well, I've got 2 digits, and I'm just choosing them for the time being. So let's go with 10, choose 2, and that's 40, is that 45? I'm sure that's 45, 10. Yeah, okay, that's 45. Now, you've kind of got, I don't like this method, it doesn't really make sense to me, but I just want to show you anyway. Your configurations are, you can have 2 numbers there, possibly, 2 numbers there, 2 numbers there, 2 numbers there. So that's 2 to the power of 4, which is 16. But then you've got to, so these are all the possible configurations, and you've got to take away all of them which suggest that you're using the case where you've just got like all of the same thing, like these 2. So then 16 minus 2, so there's 2 cases obviously, that's 14. And then when you do your 10 choose 2 times 14, you get 630. Yeah, that was just one method that I saw. It doesn't really make sense to me, so I apologize if I explain that terribly, but that's one way of doing it. The second way makes a little bit more sense to me. Third way makes 100% sense to me. So I apologize, but okay. So the second one is where we use each of these. So I got case 1. Now you've got to think about 1, 2, 3, 4. I'm only concerned about where A is at the moment. So A has kind of 4 possible positions it could sit. So it could be here, or it could be here, or here, or here. And then the B, sorry, I don't know why I drew a B there. And then the B's are kind of everywhere else. So like I could have A, B, 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 or I can have B, A, B, B. I hope you get where I'm going with this. Okay, so there's 4 possible configurations. Now the choices for my first, so I don't know, I like doing it in kind of slots. Your choices for the first slot are, well, how many numbers have I got? I've got 10, so I could possibly put 10 different numbers there. Now your second slot, taking one of the numbers out, so now there's 9 possible numbers left. Now your last 2, I can't write 8 and 7 because I'm only concerned with 2 numbers, like they've got to be 2 different numbers and that's it. So really these are fixed. So I've only got 1 choice and 1 choice for that. And those choices depend on this. So pretend that I'm not concerned with these, I'm only concerned with this one. and then obviously there's B's there. Then I've got 10 choices for this A value. Once I've chosen what A is, now I have 9 choices for B. And then because I've now chosen A and B, I have no choice as to what these other two things are. So therefore I've got 1 and 1. So then this would be equal to 10 times 9, and then there's 4 ways I can figure that. So 10 times 9 times 4. And that's 90, that's the 360. Just got an email. So that's the first case, and that's, I guess, the easiest one. The second one is this. Now it's a little bit confusing because in this case I'm allowed to order them because A has a different, what's the word? It's got, I guess, a different property because I can use one of those, whereas I have to use 3 of these. So with the second case, I'll explain it as I go, I guess, but it's kind of like, so same thing, 1, 2, 3, 4. I'll just consider A. Now, just think about the possible configurations again. So I can have A next to each other, and then I can have A there and there, and I can have A there and there. So if I keep doing this, I can have A there, there, and there, and there, and I'm missing one there and there. Okay. 1, 1, 1, 1, 1, 1. So there's 6 possible ways this could happen. So again, I've got 10 times 9, that's fixed, that's fixed. So 10 times 9 times 6. But the difference between this one and the first case is the order matters for these, but the order doesn't matter for these. And it's because A and B are kind of like this case is kind of double counted because A, B is essentially, I know that I've written it, this is why I didn't want to use prime numerals, but it kind of makes sense to visualize it. If I chose A, how am I going to explain this? I'm basically saying that these two things are the same, but they look different because the choice that I've made for, so I've had 10 choices here, and that's told me that A, B, B, but this is kind of equivalent to that because if I chose B to have 10 and then A9 or A10 and B9, it's essentially the same thing, so I'm kind of double counting them. I don't know if that made any sense, but so in other words, I have to divide this by 2. So then that gives me 90 times 6, 542, so 270. So then I've got 360 plus 270. I understand this is a multiple choice question. We're supposed to spend like a minute on them, but oh, not 540, 630. Okay, that was confusing, but I hope that I just increased the speed of my mouse. I hope that that kind of made sense. I don't know. So you're essentially double counting these because this configuration is the same as that, whereas B, A, you've already accounted for that because you've only fixed A. I don't know, I feel like I'm talking in circles. The third method makes a little bit more sense to me, and it's so it's kind of split in its 2 cases again. I won't use pronumerals this time. So the case 1, where you're looking at 1 of one number and 3 of the other number, I've got 10 numbers and I'm picking 2 of them. So picking because I'm allowed to order them, and then I'm timesing it by how many configurations there are, which we said before was 4. So that's times 4. And then the second one, the 2 by 2 case, so where there's 2 of one number and 2 of the other, instead of it being 10 pick 2, it's 10 choose 2, because again I've double counted these, which is this times by 6, because there was 6 ways I could have A. There's no comments. So then it's just 10 pick 2 or by 4 plus 10 choose 2 by 6, and that's also 630. And if you don't like the 10 choose 2, it's kind of, if you think about it, if it was ordered 10 pick 2, then you divide it by how many config. So you divide it by the order, like pretending you're trying to order these. So 2 factorial. I feel like I'm talking in circles. There's way too many ways to think about this, but it'd be the I guess the way you think about it. Like, this is the hardest combinatorics question ever asked. So I hope that you can gain some understanding from it. I certainly learned a lot trying to work through this question, but I initially thought the answer was B. I thought it was 900 at first. Every time I worked through it, because I didn't see that these two are the same. I just went with like the same kind of working out. So like this times 4 and this times 6, so that gives you 540, and then 360, so that gives you 900. I was convinced it was 900, and then there was another solution to this. Is from the HSC. This is question 10 of 2019's extension 2 paper, and there was somebody's work solutions to it. They said it was 900, so I thought, oh, maybe NASA have made a mistake. But NASA didn't release their work solutions to it, because they don't release work solutions to the multiple choice questions. So I don't know. I'd like to see their working out. But yeah. Anyway, the last question is a little bit nicer. So it's already there. I don't know why this is a band 6 question, and I can see kind of why, but at the same time it's kind of just intuitive. I'd love it if you'd be able to guess it, because I really think you would. But it's basically saying that, well, like, this is the triangle inequality, but the equal version. You know how the triangle inequality is like that. There's a vector, there's a vector, there's a vector, and call that A, call that B, call that A plus B. And it's basically saying that this distance is always going to be bigger than or equal to this distance. And the case where they're the same is basically when this is A and that's B. So that's A and that's B. And then what's necessarily true when this is the case is, well, they're obviously not perpendicular to each other. They don't have to be equal. Their lengths don't have to be equal, but they certainly do have to be parallel, because they both have to be on the line AB. So I would have said the answer, just from a complete guess, is this, and I kind of would have just moved on, not considered that a band 6 question. But if you have any insight as to why you think that's band 6, then I'd love to hear it. Or if you think there's a counter argument for any of the other ones. But I'll just work through. I can show you. There's a way to prove that it 100% is this. Well, Chloe was here for like 1 second before. It said 2 viewers, so unless there was hackers that really want to watch some extension maths. Okay. So I just basically started with what I know, and it's what the question gave me. Yeah, so these are just the multiple choice questions. There's heaps of like really long questions that I've found, so that's kind of exciting. Definitely shouldn't be band 6. Yeah, well, yeah, I don't know. Anyway, okay, so I basically started with this, and then I kind of went through the cases. So the cases being, well, I'll go through B. So just look at B. I just kind of started ticking them off, and I was like, well, would the HSC expect you to do this, or would you just be like, well, I just drew this really easy picture before? Okay, so the reason it's not B is I just kind of made up vectors that were really easy to work with and disproved why this was even necessary. So A, let's pretend these things are equal. So that's B, isn't it? Yep. And we'll do C as well. So C is going to be like the case where A is equal to B. Okay. Alright, so in order for these two moduli to be the same, I just need I basically just need the absolute value of everything to be the same. So like I could just write 1, would I write 1 minus 1 and 1, 1. Now they're not the same vector, but they have the same modulus. Their modulus being, I'm sure we could just easily work out that that's root 2, which also equals B is 1. Okay, but they're not the same. Now when you add them, so if I try and put it into here, so A plus B is equal to 1 plus 1 minus 1 plus 1. So that's 2 and 0. And then the modulus of that is root 4, which is 2, which is not equal to root 2 plus root 2 from these two. So therefore it's not B. I think it's pretty easy to see that. And again, I can just make up two vectors that are the same. So I just made one. It's really easy to prove it when you just work with negatives. So let's just make these equal to 1 minus 1. And then let's disprove this again. So the modulus of A equals the modulus of B, which is, again, root 2. Then what do I do? So A plus B is just 1 plus 1, which is 2, minus 2. The modulus is root 4 plus 4, is that right? So root 8, is that right? Which is not the same as, again, root 2 plus root 2. So therefore not C. Don't you have to prove a case that works for instead of? Don't you have to prove a case that works for the question instead? Yeah. So yes. You're right. Yeah. But I was kind of just showing why these two aren't right, which you would never. Like, this is a multiple choice question. You would never do this, I guess. But it's just kind of fun to disprove the question. Okay, let's just work through this. So you basically just got to figure out whether it's perpendicular or parallel. I seriously don't get why this is band 6. Anyway, I think this is a fun proof to just go through anyway, because it's not saying all the vectors are equal have the property. They're saying that all the vectors that have the property are equal. Oh, okay. Is that the necessarily true part of that? Because it's not saying all the vectors that are equal have the property. All vectors that have the property. Okay, so it's, yeah, you're right. So I'm kind of doing the opposite. I'm doing that rather than that. Yeah, okay. Yeah, that makes sense. What was I about to do? So you're not actually... You don't reckon? Isn't me just making up a vector that disproves this? Because isn't this saying, if this, then this? If it's necessarily true, that means this implies this. Oh, I see what you're saying. So this is basically saying the vectors have this property. Does that mean that this is true? Is that kind of what you're saying? Because the necessarily true this implies that. So that has to hold, and therefore this. Is that kind of where you're going? Because that kind of makes sense. I was looking at it the other way. Regardless, it's a pretty generous question. I'll tell you what question. Yeah, look, question 12 of multiple choice. How many questions do Victorians have? In my opinion, you have to make up a vector that has the property that disproves the option. Okay. So make up a vector that this works, and then prove that that's not true, is what you're saying. Okay, well I did the reverse. Did I? Yeah. Well, would that be hard to come up with if I've just got... I don't know, let's make one up. So if I've got, I'll use my same examples, A equals 1, 1, B equals 1 minus 1. So, oh no, that doesn't hold. Actually, let's go. So the modulus of that's root 2. Oh, I'm going to need one that's nice, aren't I? Let's go with one that's a nice number, so 3. Let me just go with a unit vector, so 3, 0. So the modulus of that is 3, so the square root of 9, so 3. If I add that to, let's make B, let's use the 3, 4, 5 triangle, so 4, let's make that 0, 4. I don't know where I'm going with this, this is just, that's 4. And then, so A plus B is the vector 3, 4. The modulus of that is 5. Yeah, this still doesn't, this disproves it, doesn't it? Because then this is saying that, so therefore 3 plus 4 does not equal 5. Oh no, this doesn't even hold. What am I talking about? They're not even the same. How would I make them the same? Oh, that only works if they're parallel, yeah? What am I doing? So that's going to be 4, 0. Which is going to be A plus B is 7, 0. So that's going to be 7. Okay. Yeah, okay. No, I've done it. Use the vectors. Yeah. So that's 3 plus 4 does equal 7, but 3 does not equal 4, and also 3, 0 does not equal 4, 0. So therefore, not B or C. Okay. I see your argument, and I like it. That should be enough to say, well, to convince yourself that, I think I get how to do this question. That should just be enough to convince yourself that it can't be anything else other than something that's parallel. Because then if I had done this with perpendicular, which is what I was trying to do before, like I had 4 and 0 there, they're perpendicular. If you want, you can square both sides of this and then expand everything, and then you end up with the fact that theta, so when you substitute this, when you substitute that in, you end up with theta equals 0, which just means they're parallel anyway. Okay, that makes way more sense. Let's go with, oops. I don't think it can ever hold perpendicular vectors. What about the two, I'm just curious, what about the two unit vectors, like I and j? So if A was 1, 0, B was 0, 1, what have we got? The modulus is 1. The modulus is 1. That's B. And then A plus B. That's just 1, 1, which has modulus 2. 1 plus 1 is not root 2. I guess maybe I could draw, so pretend that's a vector, that's a vector. So they're perpendicular. That's A, that's B, because A plus B is going to be out here. 2 does not equal the square root of 2, yeah. I like how you write that. Equals, that's so cool. So you're looking for 2 vectors. This is a cool question. Imagine if this was a question. So we're trying to make that hold. So if this was, keep going back to the 3, 4 triangle, 3, 4, 5. That was 3, 0, that was 0, 4. If that was 1, 0. What's a nice number? It's never going to hold. Why though? Is there a way to prove that it won't hold? Oops. I suppose it comes down to, so this is the solution I wrote. Oh, it's here. This basically says the angle has to be, well, cos theta has to be 1. Well, there's a lot to, I guess, talk about in a band 6 multiple choice question. Oh, well. I still think this is so easy. You just look at it and be like, oh, well, it's that. And you'd spend 1 second on it because of Pythagoras. Oh, yeah. What's this saying? This is A plus B squared equals A squared plus B squared. Oh, that's this. That's where I was going with this. No, it wasn't. What happens when we expand this? I'm really curious now. What's that gonna look like? I can't do that. Yeah, okay. Oh, didn't mean to take a photo. Why did I do that? What have I done here? Except A equals B. There are no solutions to... Yeah, and it said at the start that they can't equal 0. Oh, okay. Sorry. You've said this. Is that what you said? There are no solutions to that. Because you can simplify to a plus 2a. Yeah, is that what I've done here? Oh, 0, not 1. You idiot. Yes, the dot product has to be 0. What have I just proved? Yeah, right. Oh, yeah, okay, I get it. So I've just proved that either A or B have to be 0. Or both of them, which isn't possible. So this can never hold. Yeah, okay, that makes sense. By the null factor theorem. Yeah. Oh, that was fun. Oh my god, 41 minutes. I thought this was going to take like 15 minutes. Apologise for that, but we went on a very big tangent, so that was fun. Yeah, right. See, it feels like we're in the classroom again. That was cool. We're going to hear today whether, yeah, I'm sure you've heard that we can have year 12 in the classroom after 2 weeks. So we're going to hear about how that might work. And I'm pretty sure you'd be eligible because you're obviously in year 12 for one course. So I'm excited for that. But yeah, okay, this makes sense now. But still, you'd never do any of this for a question like that. I'm still confused by this one. I understand this one makes sense. This one makes too much sense. But yeah, the combinatorics one I don't really like. But on Thursday, I'll go through some of these depending on how long they take. There's a variance question. There's a paraboloid question. And a binomial theorem question. And I'm thinking, I only have 2 courses though, one of them. Yeah, but depends how they do it. You might be able to come in for just one, if you even want to. I don't know. School might contact you. I wonder if you'd be able to come in for our advanced, like if we're held an advanced class, if you'd be able to come. Would you be interested in coming if that was a thing? Because I'll ask Mr. Rees, because it might be the case that because I have advanced and extension, that there'll be 2 separate classes like they normally would be. You'd need to come in for trials. Yeah, I don't know what's happening with trials. Yeah, I'm not sure. Alright. Yes, you'd be interested. Oh, sweet. Okay. Well, I'll ask him. I've got a meeting in... wow. I've got a meeting in 2 minutes, so I'll ask him now. But thanks for hanging around, and I guess I'll see you Thursday. And